Welcome everyone to our presentation on building mixed reality experiences in WebXR. My name is Rick Tavernier, and me and my colleague Felix Zhang will be presenting existing and new features of the MetaQuest browser. For people who are unfamiliar with WebXR, this is a web standard that is implemented in the MetaQuest browser and other browser engines that allow you to run full-screen immersive experiences without the need for an installer. Another advantage is it's a web standard, so your experience will also work on headsets of other manufacturers. There are many sites that use this technology to create immersive experiences. For instance, the landing page of the Quest browser has a good selection of interactive demos and games to show off its capabilities. Initially, WebXR was limited to just virtual reality. At MetaConnect 2022, we introduced a host of new features that enabled augmented reality. First off, we introduced pass-through that allows the user to see their environment during an immersive session. This allows mixing of the physical world with virtual objects. On Quest 2, this is in black and white, but on Quest Pro and Quest 3, the pass-through is in full color. We also added support for WebXR anchors and added support for their persistence. This allows a site to ground objects to the physical world so they stay consistent between sessions. For instance, if you place a virtual flower pot and go back to it later in another session, it will still be in the same location in the physical world. The third feature we introduced was WebXR planes. This feature returns a set of flat surfaces representing the wall, the ceiling, and other objects of the physical world. This allows you to interact simultaneously with the physical and virtual worlds. Since MetaConnect 2022, we added some additional features. WebXR hit testing is a convenience method to raycast against the physical world. WebXR semantic labels will return you the type of object that you are interacting with. For instance, a plane will tell you if it's a painting or a wall, and you can make a decision based on that. For instance, if it's a window, you may choose to draw a virtual outside world where the window plane is located. WebXR meshes is a lot like planes, except it will return the 3D geometry instead of the flat surface. This enables better interaction with the physical world objects, because now you know their physical world dimensions instead of just the flat surface. The past year, we've been hard at work on making more mixed reality features. So today, we want to announce a couple of new WebXR features. But before that, I want to also mention that the Quest browser gets a couple of new features on Quest 3. As I mentioned before, full color pass-through was added. The device also ups the resolution, so your WebXR experiences will be clearer. In addition, AV1 decoding is now supported, which is a more efficient video decoding algorithm. The device also comes with new controllers that are exposed in WebXR. The first feature that I'd like to talk about is the ability to get the 3D geometry of the room. This is also called the scene mesh. The scene mesh is captured during scene setup and is a detailed representation of the room's geometry. You can use this information to implement hit testing, physical world interaction, or basic occlusion. As you can see in this video, the geometry follows the outline of the room. This feature is available on Quest 3 and is supported when the device ships. The second feature I'd like to talk about is depth sensing. And this one is a little bit harder to explain. WebXR depth sensing will give you the distance of the physical world on a per pixel basis. Its capabilities are best demonstrated with a demo. As you can see in this demo, my arms are interacting with the virtual object in the scene. The pixels of my hands can occlude or be occluded by the virtual pixels. Before this feature, it was not possible to occlude virtual objects with the physical objects in real time. To get even a little more technical, each frame in your headset is getting a hardware-accelerated GPU object that contains the distance to the physical world. This is also a Quest 3 feature, and it will ship in an upcoming browser release. I will now hand this off to my colleague Felix, who will give you more information on how you can easily develop for these features.
Thanks, Rick, for that comprehensive overview of the mixed reality feature in the MetaQuest browser. It truly highlights the foundation and possibilities of what we can achieve. I'm Felix Zhang, and building on Rick's foundation, I'll be delving into the array of developer resources we've created. Tools, libraries, and sample projects, all aim to enhance your WebXR mixed reality creations. Last year at Connect, we gave you a glimpse of an early version of a WebXR device API emulation tool as we showcased the development workflow of Project Flowerbed. Today, I'm excited to officially introduce the Immersive Web Emulator. This revolutionary tool empowers WebXR developers to simulate and troubleshoot a full WebXR experience directly on their desktop browsers. Boasting features like 6 degrees of freedom emulated transform control for headsets and controllers, comprehensive controller input emulation for both binary and analog buttons, and intuitive keyboard mappings for standard actions. We open-sourced this tool and released it in extension stores of Google Chrome and Microsoft Edge. And ever since its launch, it has seamlessly integrated into the WebXR development process for over 4,000 developers. So let's dive into the specific mixed reality features it supports. First, the MR environment setup. With the Immersive Web Emulator, developers can seamlessly craft a personalized MR test environment for their WebXR projects. Simply designate the room's dimensions, and the emulator intuitively spawns walls, floor, and ceiling. You can then sketch mesh outlines, creating digital representations of physical world objects within the defined space. This crafted environment, combined with the meshes, are rendered and injected into the WebXR app as the background, echoing the WebXR pass-through feature on MetaQuest browser. In the demo you are observing, I adjusted the room's dimensions, created a desk mesh, and positioned it. And these changes are reflected immediately in the WebXR app's backdrop. Earlier, Rick talked about how WebXR experiences can understand the room environment through the XR Plane and XR Mesh APIs in the headset. And I'm happy to say that the Immersive Web Emulator offers the same level of support for those APIs right from your desktop browser. Your defined floors, ceilings, and walls from the previous step are transformed into XR planes, while user-drawn meshes are realized as XR meshes. But that's not all. A recent enhancement is the semantic label feature, giving the app more insight into the virtual environment, and the app more control over what to do with the planes and meshes. As the demo reveals, each item is accurately labeled. Now, let's discuss another highlight, emulated hand tracking. Beyond controllers, the emulator introduces a hands-on interaction. Users can effortlessly alternate between emulated hands and controllers. Presently, we've integrated two fundamental hand poses, a relaxed state and a pointing pose. And for interaction, the emulator incorporates the universal pinch gesture with advanced support for custom hand poses and gestures on the way. The demo showcases this feature's intuitiveness. Concluding our suite of MR features, the spotlight is on hit testing and anchors with persistence. When the hit testing API is called in the WebXR app, the emulator performs hit testing against the user-defined walls, floor, and ceiling. As depicted in the demo, anchors can be generated from hit test results. And thanks to anchor persistence, these anchors can have a lasting presence. Stored by origin, they are consistent across sessions, behaving the same way as they would in MetaQuest's browser. While the Immersive Web Emulator streamlines development through emulation, efficient MR development also requires easy integration of these APIs into a production-ready environment. Reality Accelerator Toolkit is our answer to that. Also known as RATK, This tool enhances the widely used Three.js 3D library. It introduces binding for XR plane, XR anchor, hit test source, and XR mesh, and silently manages backend updates. By encapsulating these features within the Object 3D interface, RATK allows developers to effortlessly incorporate real-world elements such as planes and meshes directly into their Three.js scene graph. Let's take a look at this demo app to truly grasp the capability of RATK. Now, if you'll direct your attention to the demo video, a number of things are happening here. First up, check out our mesh detection in action. It's helping the app understand the shape of the desk and the screen. But how does the app know which ones are the screens? Well, that's our semantic label at work. Now, if you've noticed the shadow at some point, that's thanks to our hit testing against the planes right underneath. Oh, and how am I moving objects around? That's our hand tracking. And while it's not strictly for MR, it feels right at home here. The best part? Everything is made super easy with RATK. Pretty exciting stuff, right? But these are not the only things we've been working on. There's even more on the horizon for developers in the upcoming months. First up, I want to tell you about our WebXR template and samples project. We've heard from many diving into the WebXR realm that there's a maze of tools and libraries out there. Finding the right combination that's solid and ready for the big stage? Not always straightforward. We've taken that feedback to heart. The result? A WebXR template application in the works, powered by Three.js, equipped with tools and libraries we found super useful in our development journey of Project Flowerbed and beyond. And to showcase its versatility, we'll be rolling out 4 sample apps, each highlighting its strengths in areas from gaming to social interactions, and of course, e-commerce. Now, for a cherry on top, we've teamed up with the Oculus Star program. And guess what? WebXR developers, you are in for a treat. We're crafting a special set of perks exclusively tailored for you. More details will follow soon. To conclude our session, Meta has a special announcement that's sure to pique your interest. We're thrilled to unveil a unique opportunity for a vibrant developer community. This November, in the heart of the tech hub that's the Pacific Northwest, we're partnering with Amazon Web Services for a WebXR hackathon centered around the theme of mixed reality. That's right, it's your chance to push the boundaries of what's possible, blend the digital and the physical, and showcase your most innovative ideas. Now, I know you're eager for more detail, so to stay updated, make sure you're following our developer account on X at Oculus_dev. We'll be sharing dates, registration info, and all the finer details there. Seattle in November, mixed reality, and a community of brilliant minds like yours. We can't wait to see the magic you'll create.